Okay guys, this is going to be a relatively quick video to talk about a relatively simple concept, direct and inverse variation. We're also going to talk about a third type of variation called joint variation. We'll do that in class, I believe, but this video is about direct and inverse. So variation is really just a way of describing the relationship between input and output values, or between x and y values. For a function, and direct is a different type of relationship than an inverse relationship is. So you'll use formulas to solve these problems, and you guys are going to have no problem with this. So let's just dive right in. Direct variation is describing a type of relationship where as x gets bigger, then your y value also gets bigger. So if you have a table of data and both of your columns are getting bigger, then you may have a direct variation. Alternatively, x and y can also get proportionally smaller. It doesn't have to just be upward growth, it could be downward. But the key word to make note of here is proportion. Perhaps I can spell it. Proportion. Get it together, Annie. Okay. So the formula that we're going to use for solving direct variation problems looks like this. Y equals k times x. So our input value times k will equal our output. But what is k? Okay, k is constant. And if it helps to remember and you would like to use the Kardashian spelling, why not use a K to spell constant? Doesn't matter to me. But this means that the value of K will stay the same between the first relationship and the second relationship that you are discussing, which is what keeps the differences between the x's and the y's proportional. You're multiplying by the same number all the way down the table. So if I give you a table full of x's, you're going to multiply every x by the same number to get their corresponding y's. And so the difference between those two values will always be of a certain proportion because you're multiplying by the same number. It's not just like willy-nilly input and output. So when I say relationship number 1 and relationship number 2, I am referring to the way that these problems are often set up. Okay. This problem says if y varies directly as x, meaning y will be on one side of the equal sign and x will be on the other, and x equals 8 when y equals 16. That's our first relationship right there. We have our input and our output values. So we're going to use that information to find k. Because in the second relationship, you always have a value missing. What is y when x equals 24? I know my input is 24, but I don't know what my output is, and I can't figure that out until I know what k is. And if we're trying to solve for a variable, our other two variables have to be known values. So we're going to use this formula and these two numbers to find k, and then we'll apply k in the same formula to these numbers to be able to solve for y. All right, so our relationship number 1 is x equals 8 and y equals 16. And our relationship number 2 is x equals 24 and y equals a big old question mark. We don't know. So we are going to use y equals k times x and the information from relationship 1, 16 equals the x value of 8 and the unknown of k. So to solve for k, we'll just divide by 8 to cancel, and we get k equals 2, right? Because 16 divided by 8 is 2. So now we're going to use that information plus what we know about relationship number 2 to solve for our missing variable, because this is what the question is actually asking us. The question is not asking us to find k. The question is asking us to find the value of y if x is 24. But we cannot figure that out unless we know k. So our first step is to find k. All right, I digress. Y equals k times x. And we are going to use y equals the k value of 2 times the x value of 24. All right, and what's 2 times 24? Well, we know that. Y equals 48. So that is our answer. Y equals 48. Pretty simple, right? You're just plugging numbers into a formula. We can do that. We've been doing that all semester. All right. Also very exciting is that you can graph direct variation. And the best part about direct variation is that it's always very obvious. If you're given like a multiple choice question and that says which of these graphs shows direct variation, you will be able to spot it from a mile away, because direct variation will always run through the origin. Always. Every single time. The slope might be different. It might be a positive line or a negative line, but it's always going through the origin. When graphing, remember, y equals mx plus b is our slope-intercept format, right, for a line. And if we know that the y-intercept, which is what b stands for, is 0, then we always leave it off. We don't write it, because why waste time and energy writing a 0? And we know in direct variation, the y-intercept will always be 0. So really, y equals mx is the equation of this line, and y equals kx is the equation of direct variation. Well, that means that k is slope, and the y-intercept is always 0. So if you are given a direct variation like this, y equals 3x, where 3 is understood to be the constant, then you know you can graph that running through the origin with a slope of 3 over 1. Pretty cool, huh? And what would happen if the equation of the line was negative 3x? Y equals negative 3x? Well, then it would be running in the opposite direction, going down 3 and to the right 1. You'd have a negative line. So that's direct. And of course, we're going to throw in a curveball here with inverse, because every relationship of input and output is not going to get proportionally bigger every time, or proportionally smaller. Sometimes things are going to move in opposite directions. Totally fine. That's inverse variation. So with inverse variation, if x gets bigger, y gets smaller. And alternatively, if x gets smaller, what happens to y? You guessed it. Y gets bigger. Just like direct, these changes are proportional. With any variations, you have proportional change. Okay? You're always going to have change when you're throwing, an input and an output value into a function, creating a table. There's really, in a rare occasion, are you going to have the same values for the input and the output. But with variations, it's proportional change, and that's what's important to remember. So the formula or the equation for inverse variation is y equals k divided by x. Before we had k times x, and now we have k divided by x. Again, k is constant, so we are using the same number every time as our numerator, and that's what keeps everything proportional. So these get set up the exact same way as direct. We have relationship number 1, x is 8, and y is 23. Okay? And then relationship number 2, we are being asked to find y. What is y when x is 4? So I have x equals 8 and y equals 23. Relationship number 2, x equals 4 and y equals, who the heck knows? Well, we'll find out, that's for sure. All right. So we're going to set this up with our formula y equals k divided by x. So we've got 23 equals the unknown of k divided by 8. And we're going to unstick this division problem with a multiplication problem. Multiply on this side. And we've got our constant of 184. 184. So now we're going to set up the same formula to solve for the missing variable from the problem. We were being asked to find y originally. So our formula will be y, because that's what we're looking for, our constant of 184, and our x value of 4. And 184 divided by 4, we get y equals 46. So was this a proportional change? We went from 8 to the smaller value of 4. So our x's got smaller, which means our y should have gotten bigger. We went from 23 to 46. Looks good. Looks good. All right. You may be shown a table, just like with direct, you might be shown a graph and asked, does this represent direct variation? And if it runs through the origin, then the answer is yes. Well, you might be asked if a table represents direct or inverse variation. So the first test you can do is multiply x times y for each pair in the table. You should get the same answer every time. If you multiply x and y and get the same answer every time, then that means you have inverse variation. So let's check this one out. 1 times 48 is 48. 2 times 24 is also 48. 3 times 16 is 48. 4 times 12, yes. All signs point to yes. What does x times y equal when you multiply each pair? It equals 48. So this table is inverse. What about this table? Let's see. 1 times 2 is 2. 2 times 4 is 8. Okay, so already I know that this is not inverse variation because look, my x's are getting bigger, but my y's are also getting bigger. And if I multiply each set, I do not get the same answer. So this is not inverse variation. But does it represent direct variation? How can we test to see if there is a proportional change? Well, what's the thing that we know has to remain the same between each of these relationships? We take our input, remember our direct, now we're testing for direct. So our direct formula is y equals k times x. So we should be able to figure out a way to know what k is. And if I rework this a little bit and get k by itself, if I divide by x and divide by x, now I have k by itself. K equals y divided by x. So if I can divide y by x and get the same answer every time because k has to be a constant, then we'll know that we do have direct variation in this table. So let's try it out. My y value of 2 divided by 1 is 2. My y value of 4 divided by 2 is also 2. So far, so good. But I don't know. My y value of 12 divided by 3, well, that's 4. 16 divided by 4 is also 4. We do not have the same k value here. We do not have the same constant. So no, this does not represent direct variation. Why? There's no proportional change. You guys, can somebody just get me a dictionary for Christmas? Because this is getting out of hand. No proportional change. And we know this because there's no constant value. No constant. We tested it out There's no constant. This is not direct variation. It's not inverse variation. It's just some numbers, some input and some output randomly gathered together in a table. So just because you have data does not mean it is represented by inverse or direct variation. You got to do a little testing out. In these problems, though, however, you will be told explicitly that something varies directly or varies inversely. So those were our notes for direct and inverse variation. Tomorrow in class, we're going to talk a little bit about word problems, and we will go from there. If you have any questions, either write them down or pause, rewind, and rewatch, and we will continue this variations journey in class.